Hello, fellow NASA HUNCH educators. My name is Miss Brittany Koger, and I'm here to walk you through our investigation stations for our Lunar Brick Mold project. I did this project with my third graders here in Georgia because we cover a lot of science standards that have to do with molds, cast, and fossils, and controlling processes of Earth and Earth's surface and how all of that is formed. So that is why I chose this project for my third graders. Now you use it to whichever grade you can. HUNCH Academy is meant to be used at your leisure and however you can. We tie in as much science standards. We try to get these kids thinking with the scientific method and our engineering design process to develop something by the end of our project. And by the end, we're going to develop a mold that is going to look similar to this. And I use Tinkercad and our 3D printers to print these. If you don't have those, it is okay. Tinkercad is a free program, and I still encourage students to get on a CAD program and put their designs, their final designs on that CAD program. So for this station, this is our investigation stations for our weight and measurement with our Lunar Brick Mold project. So we are thinking of putting a base on the moon. That's what we are looking into. NASA is studying. We're going back to the moon with Artemis and going to be putting out some studying on the moon. And I am so excited to see what they find out about the moon. In our last station, the soil investigation, you got to look at different soil from Earth, and we talked about how it is different on the moon. So that helped us kind of understand where we're at with the moon. Now, we're going to use that regolith, which is the surface of the moon, and we're going to mix it with our trash, our plastic. Okay, plastic is a problem here on Earth. I hope you recycle. If you do not recycle, please recycle and save our planet. There is so much plastic waste in this world that is just sitting on our Earth's surface, and we need to take care of that. But we don't want to pollute our moon. And if we don't have a trash service on the moon, what are we going to do with all of our plastic waste? Well, we're going to put it in the auger, the lunar brick auger, and we're going to mix it with the regolith of the moon to make bricks. And our bricks are kind of an odd size, but our bricks are going to kind of look like this at the end. And this is just a 3D printed brick with PLA. So PLA is a type of plastic, so it's going to look kind of similar to this. That idea came from a lady in Nairobi who is actually using plastic waste to develop bricks to build roadways and homes in Africa. So it's a really cool idea. So for this station, you're going to need several things. You're going to need some measuring tools. This is a math and engineering station. We've got to think like a mathematician and think like an engineer. Engineers have to know the exact sizes of things before they design something to make it. So learning how to read a ruler is very important. That is something I've talked to several engineering teachers throughout the United States, and they say kids don't know how to read a ruler anymore. We need to know how to read a ruler and read them correctly. So this is a wonderful math lesson because breaking down measurements is fractions. It is pieces of a whole. How much of a whole piece is a fraction? And you can go into equivalent fractions and things like that. And we did go into that. There is a slide in this slideshow that shows you an up close of a ruler, and it breaks it down into the little pieces. Now, each inch, we're in the United States, so we use inches. And you can even do a conversion from inches to millimeters or centimeters if you want to, and go into a math lesson and tie it into your math as much as possible. But there are 16 little marks from 0 to 1, just like the same thing on a scale. There are 16 little marks from 0 to 1 pound. So 16 marks in an inch and 16 marks in a pound. 16 ounces make a pound. So we talked about that. I used a ruler. So we had a ruler, and I also had a seamstress tape, which you could use a measuring tape as well. And I made sure to tell my students that this one is actually broke down into eighths. This is sixteenths. This is eighths. Is 8 an equivalent of 16? Yes. What can we multiply by 8 to get 16? Well, 8 times 2 is 16. So it was easy to tie in those equivalent fractions with that. But you're going to need this, a longer measuring tool. If you have a yardstick, that'll work. Whatever you have to use. Remember, yardstick is 3 feet. Measuring tapes can be all kinds of different lengths. So it's really just what you have. So I told you we have different scales for this one, and I have 3 different types of scales. So whatever scales you have available to you is what you can use. This is just a basic kitchen scale where you would push on the top. I had another kitchen scale, which is digital, which which these are only like 12 bucks on Amazon. So if you don't have one, they're not very expensive. And then the dreaded bathroom scale. Nobody likes seeing this scale, or I don't like seeing this scale. I don't think any woman really looks forward to this scale. But we have all three of those scales to help us with this project. Because, you know, if the kids have never felt bricks, weighed bricks, know the sizes of bricks, how can they make a brick? How can they make a mold to make a brick? They have to think like an engineer. Engineers have to do research on whatever they are making. So that's what we're going to do today. We are going to investigate on some different sizes of bricks. So we're going to be weighing and measuring these bricks. So using your ruler, your seamstress tape, and our scales here, we are going to be weighing and measuring different types of bricks. And I had multiple ones set out, and I'll show you how we did all of that. Okay, so first, my lovely red brick. Okay, this is a basic red brick. I had some with holes in them. I had some landscaping bricks that look a little bit different. So we had, like I said, all kinds of different bricks. And we measure in 3 dimensions because this is a 3-dimensional object, not 2. 2 is flat, 3 is popped up. We are 3D, we stand up. So we have a length, width, and height, or XYZ on a CAD program. So X is going to be from left to right across. So it is the width of this. How wide would it be? And you're going to read exactly to that mark. And this is in between a 3.5 and 3 3/4. I'm not going to tell you the exact measurement because I want your students to do this. I don't want to give it away for them. So measure it and type in your information in the next slide. So X, or width, length, how long this brick is from one side to the next. And you measure that, and you would type that in. And then height, which would be our Z in a CAD program. You go from the bottom of the brick, and you measure up, and you write those in. So we measured those, and then we weighed them. Okay, so I'm going to put it down here, and I'm going to show y'all how we did this weight. So we just kind of placed it on our scale. Remember, there are 16 ounces in a pound, just like there are 16 marks on the ruler between 0 and 1 inch. There are 16 ounces in a pound. So you got to read to whatever mark. It is so many pounds and so many ounces. How many out of that? So we weighed and measured the red brick, and then we moved on. And of course, bricks are heavy, so be careful with your students. You may want to help monitor that, do small groups. I did small groups of about 4 or 5 students each, and they all had a part. Like one of them would measure the length, one of them would measure the width, one of them would measure the height, and one of them would weigh it. And if we had more than 4, we would have somebody typing in the information for the whole group, which is on the slideshow, and you can do that, or you can do it on paper if you don't have Google Classroom, or do it whole group. Then, I brought in some cinder blocks, and this is like a half cinder block. This isn't even a full cinder block. So be very careful with cinder blocks if you bring a big one because they are very heavy. And we used the bathroom scale, that dreaded bathroom scale for this one. And we weighed and measured length, width, height, and the weight of a cinder block. We talked about why they're different colors and what they could possibly be made of. And now remember, our brick is going to be more like this, and it's going to have plastic mixed in. So I don't think it's going to weigh nowhere near what those other bricks weigh. They're made from dirt and soil and rock and gravel and all that. So we don't want to really focus on how much those weigh, but it's nice to get that in their head, to be thinking like a mathematician, be thinking like an engineer and like a scientist. Scientists conduct experiments, and that's what we're doing. So then I had some Lego bricks, and this is a mega block, and we did the length, width, height, and then I used our digital scale for these, and I put it on ounces. You could do grams, and you could even do a conversion, ounces to grams, and how many grams are in an ounce, and vice versa, or however you want to do that. It's whatever standards you like to teach with math, and how far you want to dive into it. So we put it on there, and we would weigh it, and we would type in that information. So we had this brick, and then I brought in these, which are like the toddler Legos, and we did some noticing. Like my students were like, "Oh, look, this one's half of this one." So the width or the length of this brick is going to be twice what this one was. Ooh, math. Pulling those math standards in. So we weighed and measured all of those. And then the last one was just some regular old little Lego bricks. And they noticed the same thing here, that little one was half of that bigger one. So they was like, oh, I don't have to measure that. I already know 2 of this is that. So it was nice to see their answers and what they came up with. That have fun with this, spend as much time on this lesson as you can, go into as many conversions to weight and measurement that you can, and teach it how you would like, and with whatever materials you have available. You could even, if you have a brick wall, you could measure the bricks on the wall, and go out and do that as well. My students had rulers up against the wall looking, oh, is this brick the same as that brick? And they were super excited. So there will be some pictures of my students doing this at the end of this slideshow, so it will give you an idea of what we're doing. So we have more investigation stations to come. We're going to make some bricks, and then we're going to design our brick mold. It's going to be very exciting. I can't wait to see you guys for the later stations. I hope you guys have fun with this and enjoy. Bye, guys.